Hello and welcome. This is Miles here, and I want to share with you how to use Microsoft Excel to make a modified bar graph with two standard error measurements above and below. And so I've got a data set here. This was data collected from brassica rapa plants or Wisconsin fast plants, and we raised these plants, and we actually selected for about the top 30 plants, the tallest plants, and we allowed those to pollinate and create seeds. And then our second generation is located over here, the offspring population and so forth. Each of these data points is representing the height of the plant in centimeters. All right, so if I first thing I want to do is locate how many plants were in the parent population. So if I simply scroll down, I will get down to 152 data points for the parent population. So I'm going to come back up and I'm going to program Microsoft Excel here to do some of these statistical calculations for me. I'm going to start with the mean, so I'm going to place my cursor in this particular cell and I'll type in equals, followed by, I'm going to start typing out the word average. And Excel recognizes the function I'm looking for, and I'm going to select that from the list here. And then it includes a set of parentheses. What it's looking for is a starting number and other numbers to try to find the average of. One way to tell it where to average the data, or what data to average, is to click on a particular cell, and notice that it now highlights that cell. And then I'm going to scroll all the way down to my last data point. And I'm going to use the Shift button. I'm holding the Shift button in and I'll click on the last data point. By holding the Shift button in, it tells the computer program to highlight all data in between those 2 points, the first and the last. Now if I look up here in my formula bar, I see that it's now averaging in parentheses cell A1 and then the colon telling it to, which means A1 to cell A152 and all the data in between. Simply hit enter or return on my keyboard, and there is the average of that data set, the mean or average height of those parent plants. I'm going to do the median next. Just it's a nice descriptive statistics sometimes used along with the mean, and the median being the middle value of the data set and so forth. And so another way I'm just going to practice this is to do the equals button. That highlights for Excel that I'm looking for a function, and then I start typing in median, and there's that function. Select it from the list. A different way I could select data is if I click and hold the mouse cursor down and drag. I'm holding down the mouse cursor or the mouse button as I drag. This is probably my least favorite way to do it. Holding the mouse takes some fine motor skill, but I can still get it done this way. Alright, and then I'll hit the return button and go back up and see that the spreadsheet was able to locate that median of that data set. I'm going to next find a standard deviation, and so I'm going to hit the equals button and start typing in STD. Now there's a variety of different types of standard deviations out there. I'm just going to stick with the simple one here, and I'm going to model yet one more way to input the data. And so this time I'm just going to type in on the keyboard A1 and then insert a colon and then A152. And I'm just writing out the program that I saw that it performed in the previous examples where I clicked on the different cells and so forth. And I'll hit return, and there it calculates my standard deviation of that data set. For AP Biology, oftentimes we use standard errors or two standard errors to help demonstrate where 95% of the data lies within, let's say, a bell curve, and then we can use that to help make some comparisons with other population curves and their standard errors. So this particular one, there doesn't happen to be, or at least I haven't found, a function in Microsoft Excel that does that automatically for me. So you'll have to rely on your formula sheet and use the standard deviation as well as your population size. N is 152 in this first parent population set, and calculate the standard error, and then calculate what two standard errors would be. That's just take this value and multiply it by 2 and enter that in. So do a little bit of work on your calculator to find that. All right, so happen to recall what those values would be after I calculate them for this data set. And I'm off to do a little more work here, find the mean of this new data set. The only difference is this time I only have 31 plants recorded, so my population size is a little bit smaller. N is now 31. All right, next I've done my calculations to find some of these descriptive statistics, and then I'm going to use those to help graph the parent population and the offspring population using some bar graphs or some column graphs and so forth. And so I first want to go and fetch the data for the average or mean height of the parent population. And so I'm going to show you how to program the Excel spreadsheet so that you can use this as a template down the road or whatever if you were so interested. And so I hit equals, and then I click the cell I want it to fetch, and then hit enter. Again, I type equals, and I go and I click the cell I want it to fetch and hit enter. Repeat that each time here for these different values. I'm not doing any new calculations. I'm just gathering some of the data that I've calculated over on this side. The reason I like to do that equals strategy instead of just keyboarding in the raw data again a second time is that, let's say I made a mistake over here in cell 1 and this plant wasn't 3.6. I'm going to extremely exaggerate it. Let's imagine it was 1,000, much larger than the rest. And notice that all of these calculated formula areas automatically update themselves accordingly, and that trickles down all the way over to this cell as well. So there's a real nice value of taking time to program the different cells rather than just keyboarding in the data redundantly and so forth, because then it wouldn't auto-update. All right, that's kind of beyond the scope of this lesson, but just a nice little tip for you. Next, I'm on to graphing. So I need to click this cell right here, this blank white cell in the corner, and highlight the rows and columns I'm interested in. I'm going to leave the two standard error measurement values out of this. I'm just going to highlight around my parent population, so these are my independent variables, and then the results. And this happens to be, I typed it in this way because it's going to actually be fetched by the graph and used as the key or the legend title, and so I want to include that as well. You'll see what that means here in a moment. Now I'm working with a version of Microsoft Excel where charts are located in this ribbon here. If you're working with a newer or older version, most of these steps are going to be very similar. You just might need to look at a different place to find the charts. I'm going to use the column style chart and choose the one here in the top left by default, and there's my chart. Now I notice that my chart doesn't have a title and y-axis labels. I want to fix that right away, and so if I don't fix the formatting of the chart right away, and then I go and I add some standard error bars, and then I decide I want to change the layout later, it will actually remove the standard error bars. So I'm going to use the chart quick layouts here and scroll across until I find one that looks like it has a title and has a space for y-axis labels and so forth. That happens to be layout number 9. And if I hover my mouse over it long enough, it'll pop up with layout 9. And now I've got a chart. I'm going to move it up just a little bit and resize it. I like to make this a little bit bigger so that it's going to be about the size whenever I cut and paste it into a report or whatever, that it looks about like what I want it to do. And I'm off to formatting some of the things in here. First, I'm going to add the standard error bars. So I simply hover my mouse over top of one of the blue bars and then double click on it, and I get this menu that pops up that allows me to format the data series. I'm going to select error bars from the list, and I'm going to display both a positive or a plus and a minus error bar. And I'm going to add a cap to it so that it has these little horizontal lines around it. Now I don't want a fixed value of plus and minus 10 above the averages. I want to use the custom values that I calculated with my descriptive statistics. And so I need to specify those values. For above the mean, I'm going to, with this highlighted, I'm going to select 0.26, that's 2 standard errors above the mean. But that doesn't apply for both the parent and the offspring population. The offspring population was this value over here. So I'm going to tell Microsoft that I have a second data point, or a second standard error. And so I insert a comma. So I keyboard it in a comma, then I come over and I click the next cell, and I'm off to the next one here. So the next value I need to do are the whiskers or the standard error bars that go below the mean for each of these different columns. So once again, I repeat this with the exact same standard error measurements, followed by a comma, and then the second value, and then choose OK. And I'll go ahead and close this formatting box. Now notice, if you look closely, the parent population standard error bar is a little bit smaller than the offspring, which is what I would expect to see, because 0.26 for the parent is smaller than 0.38. So voila, we've added our two standard error measurements above and below. I want to do a little fancying up with some of the aesthetics here. I'm going to adjust the size of this box just by dragging it around a little bit and get it to look good. I don't need this extra little red icon or this bullet point here. I'm going to click on that and delete it. I'm going to move the key up a little higher here. I'm going to click in the white background of the graph or the plot area, and I'm going to stretch that out, just making the graph fill the space, make it look good. I don't need an x-axis title. I think that's redundant because I already have parent population and offspring population. So I'm going to delete that one by highlighting and deleting. I'm going to add a title here, and so I'm going to include, this is a height measurement, and my labels are in centimeters, and then the chart title. Oops, I just need to single click in there, and then I can highlight and add. All right, last but not least, we're going to add a quick little summary of trends. We're going to analyze this, and so I'm going to come up here and choose the insert menu and insert a text box, and I'm going to drag it over this space just below the graph, and I'm going to start typing in. I'm going to determine whether or not I believe there is significance in the change in height. To refresh your memory, we're looking for whether or not the standard error bars, two standard errors above and below, happen to overlap the other populations. If there is overlap, then there is no significant difference. If there is not overlap, then we would suggest that with 95% confidence that the offspring population was significantly taller in this instance than the parent population. Again, that's a way of communicating the significance, statistically speaking, between these two populations, that there is enough of a difference, and therefore I can make those valid claims. All right, hope you found this video helpful. If you wanted to use this graph, you could simply copy and paste it into a Word document or into a PowerPoint or whatnot. So it's easy to manipulate and move around once you've built the graph. All right, thanks, and have a great day.